but it's an open question. So that's the changing look quasars. I like to call them changing state because they're changing their actual state. The other thing that we showed here was these things called Vorwerpes. And this came about mostly from the citizen SDSS Zoo project, where people were looking at images and trying to classify the morphologies. And so one of the contestants that was doing this, or the citizens that was doing this, found this really weird object where it had this sort of, the green image was offset from the blue and red images of the galaxy, and it looked very weird. And so it ended up being called Hani's Verwerp, because Hani was from the Netherlands, and Verwerp is like, I forget what the translation is, but it's essentially some sort of weird sort of object. So Verwerps, it turns out that this is what it looked like. So it was this green object here, and the galaxy was here. And what we can explain this as is essentially that the quasar was illuminating this object, but then it turned off. And so you had, if you think about this sequence, you had two galaxies interact. This drove some gas into the center here. You ignited the AGN, you turned it on, and you also, in the meantime, you stripped some gas from the galaxies that they interacted with, and so there's some gas out there just hanging out, this tidal tail. The quasar turns on, and it illuminates this gas with UV radiation. You get photoionization, and so this is going into equilibrium. Then the quasar turns off, and you get a light echo, and so you're still ionizing this even though the quasar is off. And then you end up with something like this. So the quasar is a factor of 1,000 or 10,000 fainter now, but this is still there because it hasn't received the message that the quasar's off yet. So this isn't a sort of one-off thing, but there are other objects like this. And so this is just a sample of several of these were observed with HST. And so the green images in this case are particularly narrow line images of oxygen-3, showing you the ionization. So essentially they're just ionization nebulae. And so these all point to activity, greater activity in the past. And so going back to this plot, these are the different Vorwerpes that have been observed and sort of estimated. You have to figure out how far away this tidal, sort of cloud is from the AGN, but that gives you a time scale, and that time scale is of an order of 10 to the 4 years. And so you can essentially say that these quasars had to have changed by at least 100 magnitudes in some cases, so really quite a lot in terms of flux. But this is sort of the constraint. And so this is now on timescales that are much longer than we could have observed or hoped to observe with modern technology, just waiting and seeing the quasar to vary itself. So as we get more and more all-sky surveys, yeah.
Is only seen in oxygen, or can be seen in?
It's a full ionization region, so it'll have other lines in it, but the oxygen-3 is the forbidden line of oxygen-3 is usually the dominant one. It's the brightest that you typically see, but it'll also have H-alpha, it'll have H-beta, nitrogen-2. Yeah. It was just sort of convenient that it was imaged in the broad G-band of Sloan, and because there's no continuum out here, right? It just has emission lines, and so it just shows up in the green band because the oxygen-3 line is really, really bright versus the other ones. So this is sort of the constraints of what we can say about AGN variability. And so we think AGN are cyclical. I mentioned from the constraints we have from the galactic center that we think our AGN was much brighter 10 to the 5 years ago. And so we think that the AGNs actually are sort of percolating, and they go through these phases of very active, inactive, very active, et cetera. Over the course of the entire, sort of cosmic time scale. And so they'll turn on, they'll turn off, they'll turn on, they'll turn off. What that means is that you'll accrete some material onto the black hole, it'll grow, then you'll stop, It won't grow for a while, then it'll create some material, it'll grow. And so the growth periods are kind of growth spurts, in a sense. It's not necessarily continually growing, or we don't think it is. And so this also folds into the fact that if we look around and we look at which galaxies are AGN, we only see like 1% of them. And so if you say, okay, 1% of the galaxies are on right now, that sort of puts a time scale of sort of 10 to the 8, 10 to the 9 years as well. So there are various time scales that sort of have to be accounted for to finally think about the end product that we see today, the black hole that we see today. And so if you measure a black hole today of 10 to the 6, 2 times 10 to the 6 in the center of the Milky Way, how did it get there? When did it grow? How did it grow? That's a question we want to ask, but we want to ask it for probably all of the galaxies, right? We want to know it in an ensemble way. I'll talk about that, I guess, tomorrow on the census and on Thursday. But this is just sort of introducing time lag. So the variability difference between different bands. Right, I already showed you that the variability is much stronger in the UV than it is in the optical, for instance, and that the X-rays vary as a function of accretion rate. So what's interesting is that you can use, we want to know what the drivers, the physics of this accretion or this variability